This morning what I want to do is to talk about something which you're probably going to come away and saying, why did he bother talking about that? It was so obvious, you know? But it's one of those things that, at least to me, wasn't obvious for a long, long time. What I want to talk about is how Ruby does objects. And the reason I want to talk about that is I've now talked about Ruby for, 8 years. And the one confusion I always see is when people start doing metaprogramming. And they start looking at all these various kind of, how does things work? How does this relate to this? You know, and there's clearly no one mental model that people have about what's going on underneath the covers. How does Ruby actually do this? And that's what I want to talk about, because I hope at the end of this, you'll have a lot clearer understanding of how Ruby does objects. The other thing is that this is not just me spouting, right? I would really love if people sort of like, you know, say, hey, Dave, how about this? Or, hey, that's rubbish, talk about this instead, right? So let's make this interactive if we can. I may not be able to see you because the lights are kind of bright, but, you know, persist and I'll find you. So let's start off by talking about why we care about objects. Where do objects come from, right? Why are they important? Little pop quiz. Who are these two gentlemen? Sorry? This man is Christian Nygaard, and this man is Ole Johan Dahl. I apologize if there's anyone here from Norway. What did they invent? Simula. Thank you. Shame on the rest of you, because this is your history, this is your heritage. Back in the early 60s, these two gentlemen were asked by the Norwegian government to do simulations of naval shipyards, naval boats. And in particular, things like how they were resupplied and redocked, because it's really important to try and optimize the process of bringing a ship in, getting it all provisioned, and then sending it back out again. And at the time, they were working with procedural programming languages like Algol, Fortran, COBOL. And they started coding away, I guess, in Algol, and they rapidly ran into a big problem. Because they discovered that they were dealing with all these things that had behaviors. Trucks, ships, warehouses. But they also had all this data associated with them. What's in the truck? How big the hold of the ship is? You know, what's in the warehouse? All this kind of stuff. And they discovered that keeping track of all of the data associated with all of these things, these behaviors, was really, really hard in a procedural language. So hard that they couldn't actually write their simulation. But, being very clever people, and having a spare 5 years, they decided that the best way of solving this was to write their own programming language. And they invented Simula. Simula was written as a simulation language. But in order to be able to write their simulations, they also invented the entire concept of object orientation. Because they invented the idea of an encapsulated set of data and behaviors. Here's a truck. It can drive, it can load, it can unload, and it has the following state. It has this in the back, it has so much petrol in it, whatever it might be. They didn't call it object orientation. They invented it. If you have not looked at Simula, it's well worth it. It's, what is it now, 40-something years old? And it still has concepts in it that we have not yet adopted in current programming languages. There are some very, very cool concepts in Simula. So Simula kind of like bubbled along for a bit, and you know, during the early 70s, it was kind of like, interesting, but whatever else. But then, two other people got involved. These are probably slightly more obscure. Anyone? Alan Kay. Indeed, this man is Alan Kay. And this is a man called Moore. And between them, they did Smalltalk and Lisp. Alan Kay, in Smalltalk, took the ideas of Simula and made them the core feature of his language. And Alan Kay actually invented the term object-oriented when he created Smalltalk. And again, Smalltalk is a 30-year-old language at least. And Smalltalk has these features that most modern languages, including Ruby to some extent, does not have. Smalltalk is a remarkably pure object-oriented language. Again, if you have not yet played with Smalltalk and you're a Ruby programmer, you owe it to yourself to go and have a play. Download Squeak, whatever it might be, and play with it. Also, if you're interested in writing good code, you owe it to yourself to get Kent Beck's book. And my brain has just died. Jim, what's Kent Beck's book called? Smalltalk Best Practice Patterns. Thank you. Smalltalk Best Practice Patterns. Right, it's written for Smalltalk. It applies equally well to Ruby. It's a really great book on how to refactor your code and keep it clean. So Alan Kay invented Smalltalk. He invented the term object-oriented. He must live an incredibly disappointed life. I invented the term object-oriented. I did not have C++ in mind. I wonder why that is. I show that slide quite often to symposiums of Java programmers, and they all go, ha, 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 look at C++, isn't that an ugly language? So then I put that up. You see, the point is that what's become object-oriented programming is not the way it was conceived. Object orientation was not programming with classes. Think about it. If you have someone in your office who is unfortunate enough to like UML, right, and you tell them, hey, go design this system, what diagram do they use? What's the favorite diagram they use? Class diagram. Yeah? They design using classes, which is insane. The only good diagram in UML is the activity diagram, or as we used to call them, Petri nets. Right? That's a really useful diagram. Class diagram, heap of crap. If a programmer sits down to write an object-oriented program nowadays, what's the very first word they type? Class. Right? We no longer do object-oriented development. Or at least we don't in the more conventional languages, C++, C#, Java. Instead, what we're doing is class-oriented development. And if all you do is class-oriented development, then two things. First of all, you are not using Ruby. And secondly, you're probably not designing your programs right, because it probably means you'll be doing things like inheritance. And inheritance is the work of the devil. You should not be using it 99% of the time, because inheritance leads to coupling and all the other sins that follow along. The nice thing is, though, that Ruby is an object-oriented language, a true object-oriented language. If you were in the charity tutorial on Thursday, I guess it was, you saw that Chad and Marcel developed a program that actually had what looked like inheritance in it, and there wasn't a class in sight. That's because Ruby is truly an object-oriented language. And so, I think it really is important that everybody understands how to do objects in Ruby. So when I first came to Ruby, it was actually 10 years ago. And I really got into it. I fell totally in love with it. And I spent a long time trying to understand how objects worked. A long time. I mean, probably 4 or 5 years, trying to get some kind of model in my head of what was actually going on when Ruby was doing its objects. It's kind of embarrassing it took that long. When I finally did get it, it was just so blindingly obvious and so beautiful that I just feel the need I've got to share it. Now, one of the things that I did was I went through and read the source code to try and find out what was going on. How did Ruby actually do this? And it is helpful in a way, in that if you look at the source code, you can see that what Ruby does for objects is it emulates this idea that an object is state and behavior. And if you look at the implementation of this thing called RObject, you'll be able to find the state and the behavior. In Ruby, we call the state instance variables. Yeah? Every object has instance variables associated with it. That's where we store the state. And the behavior is, by and large, methods. We can also have procs as well, but by and large, the behavior associated with an object is a set of methods. And that's pretty obvious. You can see that really easily, and it's pretty natural to think of it that way. But then if you want to get deeper into it, you come across diagrams like this. This is actually a diagram in a source file, object.c, in the Ruby source code. And it describes the classes and metaclasses that make up Ruby. And it attempts to make clear how it is that everything is an object, object is a class, and class itself is an object. Does that make it clear? It doesn't. It's a very awkward diagram to look at because it has all these weird terms. If you actually read the comment that goes along with it, it talks about meta-classes and meta-object protocols and all this kind of stuff. It makes it very, very hard to see. So let's try and do this a different way. Let's try and cut back to the sort of the underlying basics. Let's start by looking at a really simple variable in Ruby. There's a predefined kind of read-only variable called self. You all know about it. If you're a Java programmer, you'd call it this. It's the current object. It's the object which is looked up whenever you go and do an instance variable. So if you say @Fred, it goes and tries to find the instance variable Fred in self. Because remember, self is an object, and objects are where we store state. We also use self as the place where we go and look up methods if you don't specify an explicit receiver. So if I just say do something without, if I don't say x.do something, I just say do something, then Ruby is going to go and look for that do something method in self, associated with that object self. So self is phenomenally important. Self is kind of like the thing that centers all of your Ruby code. And if you understand self, and if you can work out what self is at any point in your running code, you basically understand all there is to know about metaprogramming. Honestly, you don't need anything more than self. So the first thing to understand is what sets self. How do you get self changed? Because obviously the changes in self is what changes Ruby's view of the universe as it's executing code. So understanding what changes self is absolutely critical. As far as I can tell, there are only two things that change self. Self can change when you call a method, and self changes when you define classes and modules. As far as I'm aware, those are the only two times that self changes. So let's look at the first of those. Let's do some live coding. That's where I make a fool of myself. Excuse me. So let's have a variable. I like my cat variable. Okay, so at this point, the variable animal holds a reference to the string object cat, right? Nothing particularly exciting there. And I could say something like put s animal dot upcase. Yeah, and if I run that, oops, I get cat. Right, is that exciting? Cool, okay, thank you very much. I'll see you next year. Notice, by the way, Ruby 191 runs perfectly well in TextMate now. Use Ruby 1.9, switch to it. All right, so there's our cat animal, our cat object. And what's happening here is that I'm invoking the method upcase on animal. So Ruby says, okay, I'm going to have to go and find that upcase method in the object associated with that cat string. And indeed, that's exactly what it does. Let's go have a look at what's actually happening behind the scenes here. There's our animal variable, and it's referencing some object, some blob thing here. And the object has state and behavior. So the state of our object is the string value cat, right? It's a sequence of characters, C-A-T. Right, at this point, we're no longer talking about Ruby objects, we're talking about actual characters at this point, C-A-T. But we said that objects also have behavior, and in Ruby the behavior is a set of methods. Now, because all strings share the same basic behavior, it would be stupid to put that behavior in each individual string object. So instead, what Ruby does is it strips it out and puts it into a separate little table here, a table of the things that a string can do. And so we have basically a pointer from our cat object to a table of methods. And when Ruby sees animal.upcase, what it does is it goes to our animal object, goes one to the right to find the table of methods, and then searches through that until it finds the code for upcase. And when it finds that code, it executes it. Pretty simple, right? Now, because we have to kind of like live in the real world, I have to reveal a little ugly secret. What I called a table of methods there is actually a class. But fundamentally, all a class is in Ruby is an object that contains a table of methods. It's an object just like my animal object is, and in the same way the animal object holds the characters CAT, the string object holds the methods upcase, downcase, string, trim, whatever it might be. So when I talk about a table of methods, I'm simply talking about an object that contains, as part of its state, a list of methods. So here is the first secret of understanding Ruby metaprogramming, or Ruby object model. And that is, every single method call works exactly the same way. There are no special cases. In all cases, when you invoke a method on that object, Ruby goes one to the right and looks for the method. All right? So, what happens if I did something like, oh, I don't know, object ID, and run that instead? Well, here I'm getting, what is it, some magic number out as my object ID. Now, how does that work? Because if I go back to my diagram here, there is no object ID method for strings. So clearly something else is taking place. And that's the next part of the equation. And that is, when Ruby goes one to the right and starts searching for the methods, if it cannot find methods in this particular object, it follows a little chain called parent up to another object, another class object. In source code terms, this object is the parent class or the superclass of this one. So if you say to string, what's your parent, it would report object. Yeah? If you had an active record model and you said, what is your parent, it would say active record : base. Yeah? So the parent is simply the superclass of the object. So a method call now is one to the right, search. If you don't find it, go up. Search. If you don't find it, go up until you hit the top. And the top in Ruby 1.8 is object. In Ruby 1.9, it's basic object. If you hit the top and you don't find the method you're looking for, then you go back down to the bottom and you start looking for a method called method missing. And if it finds method missing anywhere up this chain, it will execute it. And in fact, object, or in Ruby 1.9 basic object, implement method missing, and that's what it is that reports that little error when you type a bad method name. That's not built into the interpreter. All that's doing is executing code that's defined on object. Okay, so that's how method calls work, and I bet you all knew that. There's nothing exciting there, really. But let's play around a bit. Let's go back to our animal example here. You probably know that you can do this. You can define individual methods on individual objects. There's a lot of controversy on how you spell meow. That's my way. All right. So I can run that, and my animal or my cat can do that. But if you were to take another cat, it can't say that. Only one object has that. Okay? So far, so good. But remember I asserted that Ruby only calls methods one way. It only ever calls a method by going one to the right and then up. So somehow we have to make that speak method available to this guy. How are we going to do that? How do we make the speak method available over here? The only way that can happen is if we have something here that has that speak method defined. Right? That's the only way it can work. So what does Ruby do? Ruby is going to insert a brand new thing here. This is a class, and it has that method that we defined, and it sits one to the right of our animal object. It does not sit one to the right of any other string. It's simply the class of that animal object. So when we defined that speak method, what we did was we created this thing here, we set the class pointer of our animal to be that thing, and then we set the parent of that thing we created to the original class of the animal. So think about how that works. Now, if I say animal.speak, what happens? I'm here, I go one to the right, I find speak. Excellent, just what I wanted. If I said animal.upcase, what's going to happen? I go one to the right, I don't find it here, I go up, I find it up there. So it works. And similarly, animal.dupe or animal.objectID or whatever you want to call, is going to keep going up the class chain until it finds it. So that is how Ruby is going to implement the ability to put methods on individual objects. The reason I have question marks here is that this particular class is effectively anonymous. And not only does it not have a name, it's really, really hard to see it. When Mats designed Ruby, he decided to make these little classes effectively invisible. If you said to animal, what is your class? It will say, it's a string. It lies. It's not a string. It's one of those guys. But Ruby's not going to tell you that. I'll show you a bit later on how you can get to that guy. The other problem is that there is no official name for what this thing is. Some people call it the Singleton class because it's the class associated with a single object, and there's only one of them per object. Some people call it the meta class. Some people call it the eigen class. I've started calling it ghost class because it's kind of invisible. It just sits in the background and does stuff for you. Whatever it is, Singleton class, eigen class, meta class, they are all the same idea. It's simply a little invisible class that Ruby creates for you to make certain things work. Does that all make sense? Matt calls them different things. He tends to use Singleton, but if you actually read the Ruby source code, he also calls them virtual. So I don't know. I mean, it would be really nice if he just like came down from the mountain and said, from now on, you know. But, you know, unfortunately not. Sorry? It would, that's true, yeah. So that Singleton class, and as I say, it's got lots of different names, is just like any other class, except it has a little bit set in it that says, don't reveal me to the outside world. Whenever you create methods on an object, so say, for example, I create, back here, I've created my speak method on animal. Ruby says, oh, I need to create a Singleton class. There's not one there to start with. By default, animal is just a string, so its class pointer points to string. But the first time I do this, it said, oh, okay, now I need to create a Singleton class. So it does that. If I create a new one, Ruby says, oh, I've already got a Singleton class. So I'll put the run method in that Singleton class. There's only ever one Singleton class per object, and it's created lazily the first time you need it. So that's the first part of our equation. The idea that there's two things that change self, and one, oh, actually, you know what? I probably skipped a little bit here. Let me talk a bit about how our method gets called. When down here I say animal.speak, Ruby actually has to go and find that speak method, right? It's really useful, I find, to think about the mechanism as a kind of four-step process. The first thing is that Ruby takes the receiver, this guy here, animal, and sets self to be that receiver. So before anything else happens, Ruby sets self to be that cat object. And that's why, right, we've got on the diagram, effectively, that thing on the left there, the cat object, that's where self is at that point. Ruby then looks for that method in the method table associated with that object, the class associated with that object. So it sets self, it then scans in self's class for the object. If it doesn't find it, it then does the scan for method missing. Eventually, it will find some method to call. It will invoke that method. Now, it invokes that method. Self has already been set to the receiver, to cat. So as that method executes, self is going to be set to that cat object. And then finally, when that method exits and returns, Ruby restores the original value of self. So it pops it back off the stack. If we can show that using classes, oh, I don't know, class D. So there's an instance method that sets an instance variable. So if I say d equals d.new, okay, so I'm creating a new instance of that class. If I say d.1, then what's going to happen? Self gets set to that instance of class D. It searches in the class for the method 1. It finds it. So it invokes that method. Self is set to that instance, the instance of class D. So when it sets the instance variable to, in this case, 1, it's being set. The instance variable A is associated with that particular instance of class D. We then exit, and self is reset to what it was before we called the method. So then if I had called 2, same thing happens. Self gets set to D. It goes, looks for the 2 method. It finds it. It goes to look for an instance variable called A, and it's associated with that particular instance. So therefore, it brings back the value 1. So you run that, and obviously it's going to say 1. If we change our program and instead just call 2 here, then the method call to 2 has no receiver. If a method call has no receiver, then Ruby skips 2 steps in the method calling chain. It doesn't reset self. It doesn't need to. Self stays the same. And at the end, it doesn't have to pop back the previous value of self. So all it does is the method lookup and the method call. So here, we set self to be D, find that method 1, set at A in that instance, then we call 2. We don't change self, so we simply look for the method 2 in the class D, put S at A is in that instance, finds it, it outputs it, everything's exactly as you expect. That may seem like I'm laboring the point, but whenever you get stuck, if you're doing metaprogramming, and you get stuck trying to work out how come that's nil, I guarantee that if you track the value of self, you'll understand it. Where does putS come from? That's a really good question. Let's say we always have a value of self, right? Self exists all the way throughout Ruby code. Let's just get rid of that. But, and I said that whenever you call a method, it's always being called on an object and everything else. But how come that works? Well, the reason it works is that at the top level, self has a value. Now, if you ask self what it is, it says, I'm main. But if you dig a little bit deeper and ask, what's your class? It says it's an object. Self at the top level of a program is actually a instance of an object with a couple of weird little properties built in to make things work. Okay? When you're defining methods at the top level, you're actually defining methods, I'll get onto that in a minute, but basically in the Singleton class of that object. Right? The instance variables are in that object. Now, where does putS come from? Well, putS is actually a terminal. I don't know if I got, oops, that's not right. Okay, there's more than one of them. putS is actually a method. Take my word for it. putS is actually a method of the kernel module. And the kernel module is actually linked into or included in class object. So any method that's defined in module kernel is actually a private method of class object. So when you say putS, it just basically goes to object and looks for the putS method in its method table, and it finds it and executes it. And because everything is an object, putS can be used anywhere. So I could, for example, say, just if I wanted to get really confusing, actually it might be private, I'm not too sure. Let me have a look. Yeah, it's a private method. Yeah, so I can't call it. But in theory, it's available in every object because it's a method of object. All right. So we've seen how self changes on a method call. The other place I said that self changes is on a method definition. Class definition. So let's have a play with that. Yep. So let's define a class. Yeah, why not? Okay. Now you know that in Ruby, class definitions are executable code. So if I put 1 here, 2 there, what's that going to output? 1, 2, 3, pretty obviously, right? Because the code of the class definition is executable. It's just any code like any other. I mean, if you want to be kind of obscure in a Ruby program, you can do something like this. Oops. And now it only has 1.3. It doesn't execute the class definition, right? It's just code. So we said that self always has a value. So self must have a value inside a class definition. Let's have a look to see what that value is. I'm going to output self at the top, self inside, and self at the end. And if I run that, it says that in the class definition, self is set to Dave. Well, what is Dave? Let's go back and have a look. If I say self dot, I don't know if the spec does it. Let's have a look. They've changed it in 1.9. No, it doesn't help. All right. What actually is the class of Dave? Dave is an object of class. This is where English starts to fail us. In languages like Java or C#, whatever, when you define a class, it is a definition. It's a declaration almost, right? When you say class something, that something is somehow magical. It's put into a symbol table of classes somewhere. That's not true in Ruby. In Ruby, classes are objects just like anything else. So, for example, here, my Dave is simply a constant that's referencing a class object. So I can say, class again down here. I'll get rid of that one. And I can just call a method on it. Yeah? I could assign it to a variable. I could say x equals Dave, and then I could say obj equals x.new. There's nothing special about it. It's just an object. I can assign it to variables. I can do all sorts of cool stuff with it. Yeah? It just runs. So when I define a class, what's happening inside Ruby is it creates a brand new class object. And then it assigns that class object to a constant called Dave. Inside the class definition, self is set to that class object. So far, so good. Why does it set self to the class object? Well, there's one really, really good reason. Let's say you want to define what other languages call a class method. Yeah? Well, in Ruby, you do that by saying, oh, I don't know. Def self.speak, or whatever it might be. Yeah? You may see older school Ruby programmers using that, but all the cool kids now use this. They're equivalent because self is set to the object, right? So if we do that, then I can invoke that object by saying Dave.speak, and it just runs. Okay? So most books will say that defines a class method. Those books are wrong, because Ruby doesn't have class methods. There is absolutely no difference between saying def self.speak and saying def animal.speak. They're identical. Ruby doesn't even know that you're doing that inside a class. There's nothing special about it. So what happens inside Ruby when you do that? Here is our object model, but remember I said that that class, in this case string, here's our animal. Our class has a class of its own. Yeah? The class of string is class. So if you ever invoke a method at the top level of a string, like, on a class of string, like string.new or something like that, what's going to happen is you're invoking it on that string object, so the same rules apply. You go one to the right, and then up. Right? So whenever you do a .new on a class, it's a regular old method call on the class object. It goes one to the right, finds new. If it doesn't find it, it goes up to object. Really straightforward. And we've already seen what happens when you define a method on a specific object. In this case, we're going to define a method on our class object. In my example, typing there, it was Dave. But I'm going to define a method on the class. So what does Ruby do? It inserts one of those little singleton things. Exactly the same as when I said animal dot. So now, if I said Dave.speak, it goes one to the right, finds it, and executes it. Is that cool or what? Right? At a stroke, this is called a meta-object protocol. At a stroke, the meta-object protocol of Ruby has eliminated an entire concept from the programming language. There is no such thing as static methods or class methods. It doesn't need them. All methods are the same. I think that is just gorgeous. It's really, really, really beautiful as a concept. All you need to remember in order to do metaprogramming in Ruby is that instance variables are looked up in self, and methods are looked up in self's class. One to the right, and then up. If you remember that, you know all there is to know about metaprogramming. Now, I live in Dallas, and I've got like this weird transatlantic Sargasso Sea accent. But we have a whole bunch of infomercials on TV in the States. And invariably, it's obnoxious little Welshmen that do them. And you know, the catchphrase is, but wait, there's more. And there is always more. Because Ruby then goes on and gives you some convenient shortcuts for getting stuff done. But these shortcuts are not necessary. There is no need for them in the language. What you've seen so far is good enough. But we take it one step further. As well as being able to define just methods on an object, I could say animal equals cat. Now, you see me before I typed def animal.speak, or whatever that was. All right? That's one way of defining a method on the object animal, the object cat. Another way of doing that is using this notation. Right? Class less than animal. If we run that, oops, that would help if I actually called it, wouldn't it? It runs. So what happens when you say class less than something? The less than notation basically means open up the Singleton class of this object. Start putting methods into that Singleton class. It's a kind of a shame that the arrows go that way. If the arrows went this way instead, it would be more obvious, because what you're doing in the diagram is you're moving to the right. Yeah? You're defining methods one to the right of where you would normally define methods. And that's all that takes place when you say less than. If there's no Singleton class for this object, Ruby creates one, and then it just dumps methods into that Singleton class. So in terms of our diagram, here's our cat object. Here is our Singleton class, or whatever you want to call it, that contains the speak method. Here's our string and our object. When you say class less than animal, it's as if you had the ability to say class and then whatever the name of this guy is. Yeah? All you're doing is opening up that box so you can dump methods into it. Yeah? Why would you want to do that? Well, on cats, on individual objects like that, it's not so useful. It can be occasionally useful, but it's not so useful. I personally think def animal dot something is clearer than class less than animal and putting methods into it. But you may have seen people coding, and particularly if you read the Rails source code, they do this all over the place. You may have seen people doing this. I really should make def speak a macro, shouldn't I? And I should probably learn to type. Thank you for telling me, by the way, that I misspelled that. All right? So you may have seen people do this. And quite often, they'll put the comment above it. Define some class methods. This is pure cargo culting. 90% of the people who do that have no idea why it works. They just know that if you put class less than self, then Ruby must be looking at that and going, oh, he wants to do class methods, and put class methods in. No, there is no special case whatsoever. This is exactly the same as saying class less than animal. What are we doing? We're opening up the meta class, the Singleton class, and dumping our methods into that. So in the same way that saying def self.speak here puts that speak method into the Singleton class, I can just open up the Singleton class and put the speak method into it. Now, why do I say it's more useful in classes than it is with individual objects? One of the things that I like to do with class less than self is to include stuff at the class level that's normally done at the object level. People who are new to Ruby often make the mistake. For someone who types so badly, I delete an awful lot of code during these things. People who are new to Ruby often make the mistake of defining their instance variables in the same way that you do in Java. In Java, you'd say something like, static string, whatever it might be, yeah, in your class definition. Well, people think, I have to do the same in Ruby. And so they'll define an instance variable like this, and then they'll be really surprised. Yeah, let's do some Java. All right, so we'll say d equals Dave dot new, and I'll say pd dot get Fred. All right? So they'll do something like this, and they'll be really surprised. There's a bug in Ruby because I set my instance variable, but it's not being accessed in the method. But now you know why. Yeah? Because what's happening is that instance variables are always stored relative to self. What's self up here? It's the class object. What's self when we're executing this method? It's an instance of the class. It's a totally different object. So there's absolutely no tie-in between this and this. But if we can have a method that executes when self is set to the class object, then we can get to that instance variable. So if I was to say self.getFred there, and here, rather than saying d.getFred, call it on the class, then that works, right? Because the class variable, instance variable is set to the same, the object is set to the same thing. The reason I said that class less than self is useful here is I can do this. Yeah? So what I've done, after accessor normally executes on instances of, by shifting to the right, I've made it now available at the class level. So now I can say Dave.Fred equals Wilma, put S, Dave.Fred. Oops. Too late. Yeah? That's pretty cool, isn't it? Oh, you're a hard crowd. I think that's pretty cool. Yeah? Everything you can do at the class level, at the instance level, you can make it go at the class level by shifting across one. So that's a useful thing to be able to do. And that's just an example of how we do that. The other thing you can do, and again, this is just icing on the cake, is you can inherit from an expression. Again, in the charity tutorial, Marcel gave an example of doing that. But when you say class, let's say class A and class B less than n, all right? So you look at that, and everybody says, oh yeah, B subclass is A, right? If we ignore the fact that subclassing is the work of the devil, then you look at that and you think, okay, that's syntax. So what Ruby must be doing is here, that's the name of a class, and that means subclasses, and that's the name of a class, right? By the way, the reason we use this symbol for subclassing is it looks like two horns on the side. So you think Ruby must be looking at that and saying that's the name of a class. No, it's not, because Ruby doesn't know about classes. Ruby has no idea about classes. All it knows about is objects. Remember we said that A is a constant that stores the class object. So what Ruby is actually looking at here is not the name of a class. It's looking at an expression. And that expression happens to return a class object. So if up here I said wibble equals A, then that will work perfectly fine. It's just an expression. So if I say put as the parent superclass. Right? Now that class object's been given a name A, which is why it reports A, but it's just an expression. That means you can do some fun things. I could do something like class silly is a subclass of if rand is less than 0.5 array, otherwise hash. Now that is what I call duck typing. So then if I can say p silly.new superclass. If I run that code, oh, it's an array, sorry. It should be just class, shouldn't it? What am I doing wrong? Oh, just do this. No, silly.new. There we go. All right. So that time I created a hash. Hash again, an array that time. Hash that time. Yeah? If you've got colleagues that you really don't like, but there is one really good use of this. Ruby has this really incredibly useful and much underused thing called struct. Yeah? And what struct does is it constructs classes. So I can say, let's say, person equals struct.new name age. Why not? All right? So what that does is it actually on the fly constructs a new class object. If I say, right, it's a class. And then I can create a new person. I could say Dave equals person.new Dave, and see, I'm like 27, I think. All right. Oop. All right, so it just constructs a new object of that class. But the structure itself is simply a data holder. Quite often you'd like to decorate that with different methods that do cool things. And that's kind of like a bit tricky. You could, for example, say something like def person.toS, and then you could have something like, self.name. You are self.age. All right. And then if I said put sDave there. Sorry? What did I do wrong? Oh, I put it on the wrong thing. I'm sorry. Yeah. Okay. You're right, okay. I needed to put that, okay, let's put that method on Dave just for now. There we go. All right. So I want to put that method on all of the people that I create. So what I could do is reopen that class and define methods on it. So I could do something like class person, except now I've got to make it uppercase, haven't I? And then put my toS method in there. And do that. Or, more conveniently, I think, what I can do is rely on the fact that I can subclass from an expression, as long as that expression returns a class object. In this case, I'm going to subclass from that. So that constructs a new class based on my person object that now has that method in it. And that just runs. Nothing you can't do without the other techniques, right? But the ability to extend the class and the ability to subclass from a class object are really quite fun. Just quickly, sir. That is syntax. Unfortunately, you can't override that operator. Inheritance itself is not, no. Sorry, the question was, is this less than some kind of method that's called on the class object? That would be so nice if it was, but it's not. Yeah, it'd be really cool, because then you could actually override inheritance. And you could walk. All right, where are we? Okay, just real quickly, because I know we're kind of getting up to lunch here. Just one last quick thing, include and extend. Because again, people get a little bit confused about what include and extend do. If you have a module okay, I'm running out of time, so hi. If I include that module in the class, then I can invoke the instance methods of that module. All right? And so there's a kind of like mystique built up, particularly because in languages like C, C#, C++, include is a textual substitution. Right? It goes and finds something and drags it in. So quite often people explain include by saying it takes the methods of that and adds them to that class. But it doesn't. And you can tell it doesn't because if I was to define that method there, right, it gets invoked. If I was to define it before I do the include, it still gets invoked. Yeah? So the include thing has to be somewhere separate from my class. And what's more, it cannot be my direct class because we know that that no is in class Dave. So if I do one to the right to get to find my methods, we know it has to be there. So include has to be a little bit funky. The other thing about include is that if I create an object here, then open up module M again, and change it, even though I've already created my D object. I've got to get rid of this speak here, haven't I? Even though I've already created my D object, changing the module changes the behavior of that D object. So something funky must be going on. What's actually happening is that here's this is my D class, my class, whatever it might be. When I use include in it, Ruby inserts one of those little weird funky classes, Singleton Class, whatever you like, as the immediate parent of my class. And its methods are the methods of that module. I have to draw them out here because this is separate to the module. It does not make the module my parent, or that class's parent. And it can't make the module my parent because I can include a module in multiple classes. And so the parent link has to be different for each one of those. So what happens is Ruby creates an anonymous class like that, and then using the magic of pointers, it makes the methods of this guy the same as the methods of my module. If I then define a new class and include that module in that class, then a new anonymous class gets created, and its methods also share that module's method table. And that's why, if I subsequently change the methods in that module, they get changed for every single instance of that class. But again, there is no special case here. A method call is still one to the right and then up. Sir? It includes them, basically just keeps stacking them up. So you add a new one of these guys for each module you include. Right. The meta class goes at the bottom, then your class, and then the module's going up. And in fact, it's actually, that's one of those things where I can say that glibly. It's actually worth playing with that. And you can play with it by just creating the same named method in each one, and then commenting them in and out and seeing how it works out. But you'll find it works out Singleton, class, modules, and then superclass. All right. So fundamentally, this is the picture I would like you to have in your head of what it looks like inside a Ruby program as it runs. We have objects. All of these are objects, right? Everyone says everything in Ruby is an object, right? But all of these are objects. Some objects hold state that you use in your program, cats or whatever they may be. Some objects are things that are classes. But again, they're no different to any other object. They just have state, which in a class's case is a set of methods. They have some behavior. They can do new. Sorry, they have behavior, which are the methods. They have a parent link. But that's your fundamental object model. All you have to do to get metaprogramming is understand how self works, understand how self is changed either by a method call or by a class definition, understand that instance variables are always stored in self and referenced in self. That's part one. Then part two is to understand that all method calls in Ruby are identical. There are no special cases. Every method call is right and then up. If you're inside a class object, right and then up. And that's all there is to it. That makes sense? Cool, go forth and metaprogram. Let's enjoy our lunch.